Good morning. Welcome back to another episode of Struggling to Make a Game. Where are we up to? Go have a look. I think I've done a little bit of work off video. So where we've gotten up to is we can now, if we come in here and we run our program, we can now draw multiple quads, but only with the same hard-coded texture. The obvious next thing to do is we need more textures. So I, off stream, have gone and quickly added. Will this open in Emacs? I've added a tiny font, right? So here we go. So I drew this quickly. I think it's all 8 by 16 pixels. It's slightly ugly looking. I think we're going to need fonts for like menus and things anyway. So this probably is all temporary and gets replaced later, but at least gives us something to work with. So yeah. Now, what we need to do is, oopsie daisy, wrong button. We're going to need a bit of a plan, I think, because it's still kind of early in the morning. I'm not sure my brain's fully turned on. So this is where we're up to. Load this sprite map, yada, yada, yada. This is a thought that occurred to me, that the way we're handling our sort of window transparency, we're dropping fragments in our fragment shader. I think we might be able to get away without our blending, so that might be just a simplification we can do. Let's just make a short-term plan as well, though. So what actually are we going to be doing? So we load the sprite map, we set up our texture map so we can easily draw quads. So I guess step one is read in our new font PNG image and hard code each quad to a different letter. I guess then step two will be wrap that into a nicer interface. I'm trying to think if there's anything else. And we might need to start thinking about how we do layout in our actual app. Which is a problem I've never really stopped to think about. So I think the Brackeys program that I've shown a few times, it had a camera. It was kind of a 2D platformer looking game. And so the whole layout was just sort of make sure that the quads are drawn in a way that squares are actually square, right? Like get the right ratios. And you could zoom in and out. But everything was that one. How do I say this? Everything you saw on the screen was a view into that world. So I just had to have that one sort of like quote unquote camera and sort of project everything onto the screen. Whereas our Tetris game is not going to have a movable camera. It's going to have kind of an area you're playing Tetris in, and presumably some other areas with text in, like your score, something to show the next piece, something to show your held piece, all that sort of thing. Okay. So yeah, I think we'll have a sort of pause and try to work out what we do with that. But step one is to read in our new font PNG. I think we do all that in renderer. Somewhere in here we are making our texture image. That's a point actually. Let's make a font texture path. We'll call main.font. And we'll rename this to Smiley. Oh, that's another thought. We might want some way to set a color. Some way to draw without a texture, so just using a color per vertex. I think that'll be useful. I think that might be useful actually in the game in the end. So like if I've got a black background, it would be a shame to have a sampler for a texture that's just a black pixel. Like let's just send through a black background. Oh, I keep yawning. Oh. But we can think about that. Even if it's not useful for the game, I think it'll end up being useful for debugging. Right, to be able to just set a thing to a color and see what's happening with it. Oh, bugger. I keep doing that. Okay. Where were we? We were in renderer. We have done something in here which breaks the places it's using. So, create our texture image. Are we going to create a single texture image still? I think so. Right, I think we create a single texture image for this kind of like sprite map. And then we're going to pass through our... Or we're going to then use like pixel positions to give us access to different texture things in it. So I think this still works. We can have our font goes in here. Oh my god, struggling to type. There we go. Font goes in here. That gets us our image. What's it saying? In fact, this whole check does nothing at the minute, does it? We might be able to do this. I did have a quick look. I think I've messed something up when I made my font, and it's got some non-zero alpha values in it, which I think is just that I did it all in Critter, and I think I've used a like an eraser or something to rub something out. So I've literally got like an alpha value 2 thing somewhere that is like to your eye invisible, but just annoying. So that's something I'll fix off stream because that sounds laborious to actually track down. So what does that do then? So that should work, right? That's just transferring across our image. If we go ahead and run the program, we've not run anything yet, so let's go run.sh. There we go. Beautiful. That looks more sane than I would have guessed. Okay, yeah, because we're only sending the first like few hundred. So I think our image is massive, right? But oh, in fact, this might help us find where those badly done bits are. Or actually, no, they're not the same in each, right? So if I was looking here, like the M's missing a bit, the 3's missing a bit, the S is missing a bit, but you see that they're not the same from one to the other. So I guess this is more about how it decides. So if you've got a 1 pixel thick line and it's kind of sampling into that on a surface that's smaller, so it's got less pixels available than what your input has. I guess it has to decide somewhere like, actually, I'm going to drop that line. We're not anti-aliasing or anything, so you just lose it, right? If it's nearer the pink, you get the pink. But that does mean if I go to my hard-coded data in here, I should be able to say in here then that you're 0, 0. You're, instead of 512, well, that's the up and down coordinate. So I think they go up to 16. Like that. And then this one would be 16 and 16 like that. Because the width isn't 16, the width is 8. So we go and do 8 and 8. We should get the letter A. Beautiful. Let's do the same with these. But instead of 0, 0, we'll move along the next letter. Yeah, 8, 16, 16, 8. 816, so that should give me a B. No. Okay. One, two, three, four. Why has that got a 0 in it? 8, 0, 8, 16. 16, 0. Messed that up. All our 5, 12s and 0s back in. Right. We do want those 0s to be 8s now. We've moved along. And we want these to be 8 higher. Like that. These ones can be 0, and this should be 16. This should be 16. We get the letter B. And it all overlaps fine, because there's no logic change. Should we do a C as well, just to complete the example? So you'd be 16. You'd be 16. You'd be 16. You'd be 24. You'd be 0. 24. And 16. It goes in the middle. Cool. That works nicely. Changing main, that's what I was just doing. I've not staged anything. I'm an idiot. Nothing staged. Oh, I didn't know to do that. It's a nice shortcut to know. You don't have to stage everything first, you can just commit. So what do? I'm using font PNG and hard coding ABC in our vertice data. Cool. So that's nice, if not super useful just yet. We'd like some way to draw a texture without... Sorry, some way to draw a quad without any texture. So what I'm thinking there... It'd be nice if we could have I think these all might be wrong. Let me just go... Just delete these. So we've got A, B. This is currently C, and I'd like to make that, I don't know, a blue square. How would we go about doing that? So we've already got color set. So one thought could be that these are all 0 unless we want a color. So if these are set, they just override, like it's an override color. It does mean you can't draw black. But maybe you just set it to be tiny and it's good as. Alright, so that's what we want our sort of standard draw to look like, and it looks like that. I mean, is there another way of doing that? We could put an alpha value on it and use the alpha value to say. That way you could draw black or white, like we don't have a sentinel color that we care about. That might be better, right? So we might care later that we want to be able to draw. And particularly because it's black and white, they're both the kind of thing that we're likely to want. It's not like some off, like, magenta shade that nobody could care about. So let's stick all our things in to be 4D now. So this is the one that we are going to draw. Blows up because we now need to go update our vertex to say this will be a vec4. The binding description updates itself because we've used size of. And then that's the position. That's the color. We'll now have to have another digit into it. That should just work on that end. Don't know if it'll just compile though. Hey, it does. Obviously our shader isn't using it yet, so if we go to our vert shader, and color is now a vec4. Frag color is a vec4. Texture coordinates, and they will pass through to our fragment shader. That's a vec4. Frag color's even used anywhere now. Is not. Right, so I know branches and shaders are naughty, but I don't think we have a reasonable other thing to do at this point. Sorry, I keep yawning. Oh. GLSL has like a ternary statement, so we can inline it. Have a look. Let's see, GLSL ternary. Specification, ternary selection operates on 3 expressions. Hey, that's fun. Do you gain anything by doing that way though? Didn't jump actually to it. Page 38. I guess it's going to be page 38 of the PDF, not of the... whatchamacallit. There we go, ternary selection. Evaluates the first expression, which must result in a scalar Boolean. Selects to evaluate the second expression, otherwise the third expression, only one of the second and third is evaluated. Second and third expressions can be any type as long as their types match, or there is a conversion can be applied to make them match. Okay, so it's just syntactic sugar then, right? It's not doing anything clever. It's still a branch that our shader needs to care about. I don't think it's worth us worrying too much at this point, so... how do we do this? But we do want to assign out color. Right. So one of the uses for this, I would suspect, is seeing the bits that are meant to be transparent. So I think this comes before we do our texture. Out color equals frag color. If we do it like this, if frag color dot a is 1, we set out color to frag color and return. And we need to remember it's one of these languages, everything gets one of these. Else, we come down here and we set it to the texture value. So branches aren't good in a shader, if I remember right, because the way that shaders, or the way that GPUs run stuff so quickly is that it's doing the same line of code in parallel across a bunch of input data. And basically every branch point forces it to just stop doing that. So if you get to here, and half of your kind of, I think they call them waves, like half of the set of values we're calculating over is at this line, and half go one way, half go the other. It can no longer do them all in lockstep. So it will then have to go and do this for the ones that need it. Then it masks those out, and it does this in parallel for the rest of them. I think this is sufficiently simple at this point that we don't care too much. So we run that, and we get one black box. Nice. Come back to look at our thing in main. Why are you blowing up, though? I just need to restart LSP. Yeah. Alright, so what if you instead were an RGBW? This is what we had before, right? So I can go R, G, B, and white. Cool. I mean, that's pretty neat. And the transparency stuff all works reasonably. So we could set, what is it, Z3. So higher numbers are coming towards us. So if I make that a 1, kill this and we rerun, it should be over the top. And if we make it 0, it should go underneath. Beautiful. All right, that seems useful. Let's go ahead and just stage that quickly. So support overriding. What should I call it? It's an override color. Let's push all that up. Cool. Oh my god, that's slow. There we go. Let's go back to our README. That works. And then a helpful bullet point, wrap it in a nicer interface. That's possibly going to take a second to think about. I might take a short break and go grab a cup of tea. So expect the time to jump. I'll be just a minute. Okay. Got a drink. Got to think. Wrap it into a nicer interface. So yeah, everything we've been doing so far is very manual. Actually, main.o is probably the best place to look. So we obviously don't want to have to actually manually write this over and over. It's also hard-coded, which isn't ideal. Now, when I've done this before, I think what I tried to do is write something that was kind of, I guess, like the game object, and I would have it output what would the right way of saying this be? A game object that has like a more sensible sort of like, this is how big I am, this is where I am. It would output into a global buffer that was then what I copy data over to the GPU from. And I guess it's a slight misuse of vertices and indices. Normally, if we're doing like 3D rendering, you don't want to be sending vertices over and over, right? You'd want to be sending your vertices once, put them into device local storage so they're fast, and then you would use, I guess, like uniform buffers or or push constants or something like that to update like the indices for which of these you're actually drawing, and to update like their positions and things like that. As in, you would have like transforms that you'd send. So it would take the vertex buffer would just have like, I can't remember what people tend to call it, but I guess you have like your model, right? And you imagine that just sits kind of centered on 0, 0 at some size, and then you would send transforms to smush it and mush it and turn it and put it in the right place. What we're doing is much, much simpler than that. So I think we can get away with just having a host accessible, host coherent buffer that we just write to each frame. I'm going to stick with that idea, I think, and just make this some like global buffer. I did commit what I'd done, didn't I? Yeah. Where should that live then? Does that live in renderer? I'm going to say it does. So let's go ahead and say we have a vertex buffer, which is going to be, I don't know. How big's our vertex buffer going to be? 10,000? And then vertex buffer size vertex. Will just be 0 initialized at first, and then we'll have an index buffer. I guess similarly. We'll make 10,000, and we'll have an index buffer, which will be index buffer size. I think they're U32s, if I remember right. So if we do that, alright, so we'll come to main Odin, and let us go ahead and take all of this and all of that and get rid of it all. Maybe it should live in main because that's where all the global stuff is. Okay, I'm going to stick it in here and not think about it too hard. So, what do we want to do with this? Maybe not that. We say inside of init renderer, I'm going to have a thing right at the start that is like set up hard-coded data. Stick it all in there and format it. And instead of doing this and that, we can do, how do I do multi-line again? Something like that. Do indent tab. Yes? No? Going on. I remember how to do Emacs. If I could select all of this, like that. Get me multi-cursor. Come up to here. And then what are we saying? It's vertex buffer some number equal to that. Right? And then the numbers are all going to be different, so there's probably a clever Emacs trick to do that, but we're just going to go through and do it manually. Because there's not that many. You don't need to be there. Or B. 4, 5, 6, 7. That doesn't need to be there. Red, green, blue, white. 9, 10, and 11. Why can't I do that? Because it's cannot assign to vertex buffer. Ooh, interesting. Why? it's done like that. Does it need to be declared like this? That fix it? Okay, so yeah, so the the syntax node in is that means, I guess, like compile time node constant. I guessed for a array that it meant the array was constant, so it would have like a constant size. Basically, it's pointing to a constant array, or a constant slice, or whatever the right word would be. But apparently, no, it means the data in it's constant, I guess. Well, useful to know. And then let's see what that would look like with this, is we would be saying all of that. We would be getting rid of all of these. What else would we be doing? I guess we're going to select all of this. We'll do that same trick again. Let's get to the end of the line. Come back one. Didn't work like I wanted. Right way to do this. I try to be smarter than I am and suffering for it. So I really want index buffer at some value is equal to something. It's not what we want here. It's not what we want there. Then we can jump to this. Zero, 1, 2, 4, 5, 6, 7, 8. Oops, 9, 11. This all feels very laborious. I'm sure there's a nicer way to do this. Well, I know there's a nicer way to do it, because if I really wanted, we could just write a function, right? Emacs is an Emacs Lisp interpreter. I'm not feeling that committed at this point. But I guess if you are watching and you are an Emacs wizard, one of the things I'm hoping to get out of this series is hearing from people who know more than me about stuff. So whether that's graphics and you can tell me, actually, this is a terrible way to do this, you could put that in as a comment. Or actually, I anticipate probably more, hey, here's a useful like Emacs trick or like CLI trick that you've missed. We're all just aiming to get that little bit better. Do save. Blows up. Because on line 446 we're using something. That's interesting. You now the vertex buffer size. That's quite nice because then we can search for it. And jump to nya. You just do it like that. What we done there? Pass that straight in. Just be a vertex. Suck at this. Vertex buffer size. You still don't work. You do need to be a raw data, that thing, do you? No? There we go. Alright, that took some doing. In here, we now have all the same problems, but for our indices. So let's go ahead and say index size. And what are you? Raw thing for index buffer. Nope, because it's not a raw data anymore. It's address of user can just index buffer size. Still not done, because then this one, that's quite nice. We can just go index buffer size. Cool, that's our last error. So let's try that again. Excellent. We've changed nothing. But we have changed something, right? Because did we even change anything? Yeah. Yeah, because where before we were just hard coding data in to the slice. Now we've got a sort of static slice or a static array that's already being allocated that we can now insert values into. So we could do something like when you press space, we change how many we show. So we learn we don't actually have to stage them. We can just commit straight away. Global host vertex and index buffers. That feels a reasonable step one to me. What do we do next? So I guess the next thing that we're going to need... Something it'd be useful to get to a place where we could say, I want to draw a string at a position, which will obviously require us being able to draw specific letters at a position, which will require us being able to refer to each of the letters in our texture. All right, we have a kind of rudimentary font that we can use. So maybe the next thing to do is make this bit where we're making texture coordinates less manual. How do I want to go about doing that though? So I guess if we use the position of the, I don't know, the bottom left. So 0, 0 is not a bottom left, is it? I guess these things are all going from like the top left. It's one of those things, I don't know if this is just me being a bit slow, but I find it endlessly confusing. There seems to be, I guess, like a standard in graphics that your x coordinate increases left to right, but your y coordinate increases top to bottom. But that doesn't seem to be done consistently everywhere. It seems like, I don't know, a quarter of the time things are done, I guess, like you would in maths. So increasing bottom to top. It just, I mean, I find it confusing to the point that I don't really think about it too much now. I just kind of do the thing. But yeah, so that means that for any given value, if we know its top leftmost point, so in this case it'd be 0, 0, we know the width and the height. So in this case it's 16 and 8. Then we can generate these values and put them into our vertex buffer. And I think this is what I was saying. So I think when I've done this in brackeys, I think I had like a struct drawable with these values on. And then you have something that says like draw drawable, and it will insert the relevant values into the vertex buffer and index buffer to actually draw the thing. And then your game objects just need to have values that they can put into drawable, and everything's fine. Maybe that's the thing to do. And then I guess you need some way to map between, in that case, it was a game world position and a screen position, which isn't too terrible, I don't think. What are we going to have to do in this? I guess in this one, we're going to have like different containers. Let me try and sketch it out, because I'm not sure I've got this quite right in my head. If we think, I've got my drawing pad this time, so hopefully this will be beautiful. So if we've got our screen, told you it'd be beautiful. Imagining that what we'll likely have is, at the very least, is on this side of the screen, we'll have like next and the piece that you're going to get next. You might have your score over here. There might be some other section in here with useful stuff, like I don't know. And then your actual game is playing over here. So in this side you have your piece that's dropping. Let's make it a square this time. And you have all of the stuff you've already done in here, right? Nice Tetris. So if we imagine that we're going to want to have an object that is like a string I'm going to draw, so this next is going to need to have a position and a width and a height. Which means that probably what we have, another container, probably this container defines this is my base point, and this is my width, and this is my height. And then we'd have a thing over here that has a pos, an x and y value in it, dimensions with width and height in it. I guess it must have children as well. Because then our next here is probably a string with the pos x and y. I guess the thing that would be nice would be able to say that this point is given from here rather than being given relative to the screen. So that if, for example, we implemented something where you could click on this and drag it to change the screen size, or maybe even actually the screen size is changing, is something that we're probably going to need to handle. Then, we could have... yeah, then we could have our red position not change and just update the container's position. Maybe better than having it know its children might be for this to have just a parent container. Maybe with some ID, so it can look up the parent and find its position. And then we know our position. If we take those two and add them, this will then need a dim, which will be a width and a height, right? So I think our UI layout is going to turn into something that takes a bit of thought. But I don't hate the idea of a drawable. I think position, dimensions, potentially parent eventually, but we'll worry about that in a bit. I guess for now, let's just draw a thing onto our screen. And then we'll do this kind of relative positioning stuff later. So I think step one of that is we're going to need to generate... That's the other point, right? Is our drawable also needs to know texture coordinates and override color. Right. So that we can fill out those vertex and index values. Well, specifically the vertex values. The index values, I guess, just increment kind of dumbly. Right. I'm waffling now. I'm trying to put off actually doing it. So, we will want some code to associate each letter in our font with a texture coordinate base plus width plus height, because currently it's trivial. Currently they all are 8 and 16, but I think we should plan ahead, because that's not going to be the case past this simple example. Once we've done that, I guess, do we want to have like game state with a list? We're going to keep using the word drawables for now. And a function populate vertex and index buffers from game state. That sounds pretty reasonable. I want to use those to make a drawString function. And I guess drawString, should say, will be drawString that'll take foobar and a pos. Then it'll work out the width and height and put things in the right place. How's that sound? I think that sounds like a plan. Right. Let us see. So currently we do our texture stuff as part of... Yeah, we make the imagery source. We might want to pull our texture stuff out of this. Alright, so all of this handling. That's annoying. Actually, yeah, this is the point where we need the data. So I quite like keeping the data creation near to the point where it's needed, because it makes the basically it makes this memory management really easy, right? We can just free it once we're outside of this area because, you know, we don't need it anymore. If I pull the image loading out from here, it'll become another thing we have to manage that could go wrong. So I think we do leave it in here. Do I even need to load that though? I don't think so, right? So we could just go and hard code this. Right, I'm making terrible content now. Thinking, not talking. Yeah, so we know the values, right? We don't have to look at the data to go and get those values. We could do something smart to make these like auto-generate. Right? Like we could put the... What could we do? We could put like a known color to make a box around each sprite and then have it auto-generate the values. Maybe you can attach metadata so you can associate those to names, but that all sounds fraught with bug potential. I think we might just do a dumb list. Or a function. Right? Particularly because these are ASCII values. Yeah, so I think in the future we're going to have to make a DOM list. But for specifically for fonts, I think we can do something kind of cute. What do I call it? Sprite.odin? Font.odin? Let's go with font.odin. You're in package main. You go and say get letter. No, get ASCII. Font texture data. Coords. They're not going to be coordinates, are they? It's going to be a base coordinate, a width and a height. Get ASCII font texture. Okay. Let's do this for now then. So get ASCII font texture data. Be a procedure that takes in a character. It will return us. What's our struct going to be? I don't know what to call it yet. but it's going to have like base. Do we have a pos? No? They're not come up yet. So if we go ahead and say pos structure. Now, do we want to do that as a float? I think we probably do. So x, y, float. Base is a pos. I'm going to want to have dimensions as well. We're going to have a width and a height. I'll also make floats. Base a useful way to say it. Well, what I mean by base is kind of like a corner of it. I don't want to make it out like I'm drawing it where the middle is. I think that makes sense. And then it gets dimensions. And then this function down here, I'll take in that value. And you, sir, will return a foo. I guess I'll call this texture data. How about that? How about that? There we go. So, this one can say if our character is greater than A, or I guess greater than or equal to A, and our character is less than or equal to Z, because I'm pretty sure they count up. We're in the first row. And here, if character is greater than or equal to 0, and character is less than or equal to 9, I'm assuming they count like that as well. That's probably worth a quick double check though. ASCII value for 0 is 48, and for 9 is 57. God damn it. There you go. So, this way we know that's what we're doing. Should we just say each of those should do their thing, else it's unreachable. We should never get down here. Unreachable, take an argument? No, just no returns. So, if we get to here, then we can return base equal to x is equal to something. They are 8 wide times car minus a to get the count of how far across we're going. And we'll cast that to a float, I guess. Nope, because I'll cast that to a float, I guess. Cast the whole thing to a float, because they're both integers, so that should work fine. It should never underflow, because we've checked what our bounds are. Y is 0, because we know we're in the first row. And our dimensions can be... what? Width is 8. Height is 16. And this one is similar, except the base will be 16 greater. Right, so we have base. No, so the X stuff's still the same. So the 8 times cast 32, our character minus 0. Y will be 16. So we're going to start on the second row. And dim. These are just hard coded to be the same for now. Cool. So this only works for our already done font, but it gets us something working quite quickly. I say it works. We should probably check that. How would we check that? Inside renderer, well, we're making our hard-coded data, which is right at the tippy top of the file. What is it we're saying? Let me go ahead and say character texture data is equal to get ASCII font text data, let's say it's letter A, and then we're going to say here that this is, God, I've made that far too long. Can I just make that texture data, TD? Texture data dot base dot x texture data dot base dot y. You need to be done like so. Right. And actually, they're all going to be variants on this. So we're in here. Probably actually useful to look at this first though. So that was 0, 0. This one is going to just be plus height on this side, plus td dot dim dot h. This one will be plus width on the x value. So plus td dim width, and this will be plus both. TD dim h and TD dim width. So this might actually be useful to just quickly comment these other values out. Similarly for this. So let's get just the data we're actually messing with visible. Recompile. So we get the letter A. Letter A. Let's not be quite so British about the whole thing. Switch you to a B. That should work for everything up to the end of the alphabet. So let's switch you to Y. And switch you to Z. Nice. And it should work for our numbers. Ooh, didn't work. Why is that? See, renderer. What do I call the file? Font.odin. Did I put 0 on the end of our... What's it? Right, let's see. If I do that, does it then work for everything but 0? And then if car... This is on me being stupid, I think. Return base is equal to x is equal to 8 times 9. That sound right? Sorry, let me just do this quickly and then I'll try to explain what's going on with it. Yeah, there we go. Back to renderer. Make you a number 1. Nice. Make you a number 8. Nice. Make you a number 9. Last one to check. Nice. Yeah, I think what I've done there is if I go open font.ping and we do some big zooming. I've put 0 on the end, so I can't just use the ASCII values because in the ASCII value, 0 is at the front. So that was an oversight. But we've got something working there. Right, so we can now generate our font texture coordinates. Let me go ahead and just quickly. Oops, hang on. How do I? I gotta get out of this. How do I get out of this? Do I just kill the buffer? Sage all of it. And say in here, helpers for rendering our janky font. Okay. What next? So I guess if we're going to do this whole drawable thing, then really what we've got is every character is a drawable. And a drawable needs all these things. And so maybe the next thing to do is to... What is the next thing to do? Drawable.odin? Just to keep the stuff easy to find. So if we go ahead and say drawable.odin. What do we want to do in here? Sip of my drink. Go ahead and have a drawable struct. Drawable is a struct that will take in a pos. Maybe all that font stuff should have gone in here. Excuse me. There we go. I kind of think this stuff can go in here. Let me see. So drawable.odin has all of this stuff in it. It'll have a position, which is the position on screen. You'll have dimensions. Drawable pos dim. What else? Drawable pos dim. The pos and dim will be the positions on screen. We're going to need to have texture drawables, or that could be texture data, which is the base and dimensions on the thing. Got to decide, is this going to be center position or one of the corners? Not sure yet. Corner gut feeling sounds like it'll be easier. Right. Right. All that are drawable. Then I guess, have we got a game state somewhere? Got a global state. We haven't got like an actual game state yet. Oops. So I guess if we have a drawable, we want something that says draw drawable, right? That will go and write it into those backing buffers. So as you're writing the game code, you shouldn't really be manually touching those backing buffers. There should be a bit of bookkeeping being done for you that handles all of that. Okay, so let's go to where we're newing up all of our data. So we're in here, and instead of just doing that, can we say drawable will be drawable at some position. Sorry, what's it called? Pos. We'll have an X. No? Yep, X is minus 0.5, Y is minus 0.5. Oh, does drawable have dim? Yeah, it does, right? Because that's the size in the actual world. So let's go ahead and say you are going to have a width of 1, a height of 1. Then you're going to have texture data is our texture data that we've already made. And then that's another point. Our drawables are going to want a override color, aren't they? So drawable, pos dim, texture data. Worry about the override color in a bit. So once we've done that, then actually these values all can be pulled off of that, right? So we have drawable, pos X, drawable, pos Y. Ah, of course you got a Z. So this is something that put it on pos. It feels wrong to put it on pos. I'm going to make it just a Z value that we pass in. And your Z will be Z1. So the Z stuff is how we're doing our depth buffering. If you've not seen the earlier videos, it won't affect how anything is drawn in terms of like perspective, but it's going to be how we control like the layering of things. We might pull it out, but actually, if it's going to prove worth having, this is where it proves worth having. So, in this kind of logic that I'm coming up with here, right, where we're going to have a game state that will generate out a load of drawables, and those drawables will then dump vertex and index data into the backing buffers that get copied over to the GPU each frame. If we didn't have something to kind of give each value a depth, we'd have to care about the order we wrote these things in. I'm hoping that this depth comparison stuff means we don't. We can just dump data, right? If the data's there, it gets drawn like we want. So let's see how that goes. So we've got that. This is our overload color that we currently don't care about. And then this one is going to be drawable pos X. You're going to be drawable pos Y plus drawable dim height. That is just drawable pos Y. This one gets the width on it, so drawable pos X plus drawable dim width. And then this one gets both. drawable dim width plus nope. User are drawable pos y plus drawable dim h. That should look exactly the same. That gives us a bit of a blueprint for our drawable, right? It does mean that we have a bit of global state, which is what index are we writing? Let me just do a quick commit, because that seems a useful little bit of stuff. So work in progress towards more reasonable drawing interface. Right, this all looks slightly ridiculous doing it manually, but now what we can see is given a drawable, we can just generate all the rest of this stuff. I think means we can get rid of this and our other comments. Right, because we're not going to be hard coding these now, we're going to be actually doing it. So when I'm saying that so we have something like that. What do I do? Z1's not a thing anymore, so let's go ahead and make those drawable.zs. Cool. That all seems pretty reasonable to me. So yeah, we're now going to have a bit of global state, because you can see obviously if we were to draw another thing, we can't just do 0, 1, 2, 3 again, we need to increment this value and this value. That probably does need to be state in the renderer. Or does it just need to be some global state in this file? Does anything else ever care about it is the question. Don't know. I'm going to stick it on the renderer, just to avoid the extra global value floating around. That daft, because our other stuff about this is all global anyway. Alright, I'm going to put them up here. So, go ahead and say like vertex index. index. That's probably a bad name. These could probably be wrapped into something more useful as well. Ugh. I'm kind of okay with these being not growable. At least at first. Because I think we should be able to say, for our simple game at least, quite constrained. Like this is as big as we're expecting this to ever get. And do it all up front, and that feels like it's probably the simplest way to make this performant. I hate vertex index. We're going to go with it for now, though. Because I can't think of a better wording for it. Tell you what else we're going to do. We'll just have a global drawables for now. So drawables, which is going to be, what do I call it? How'd you do uppercase a thing? God damn it, I know there's definitely a way to do it. I can't remember what it is. Drawables. Size can be 20 for now. Drawables. Size. This is going to be of type drawable. Why are you unhappy? Drawables. because that needs to be capitalized. There we go. So this probably does move to our game state later. Or become something... Oh, God knows. Let's worry about what we do later. What I want to be able to do is I want to be able to have drawables naught be equal to drawable. In fact, let me go ahead and just inline this. Right. We bin that. So are going to be get that or some letter. And you going to go ahead and say something in here, like take all of this. Going to have something like drawable, proc. Takes nothing, it's all global state. Do this at work, I would get sacked. I don't know, probably does take... Alright, let's say drawables. We're going to use that global state. And we're going to go ahead and say, what, for each drawable, right. Draw drawables. When you call draw drawables, do we want to have it assume that those indices are set to 0? Probably not. I think we're going to have it set them to 0. In which case, they probably could be local to this, right? Rather than global. And that feels less grim. So let's go ahead and do that. And in fact, actually, that probably means we can have it be... Yeah, we could have like a drawable count. Means we could have an index that we use instead, right? So this here is the drawable count times 4 plus 0 plus 1 plus 2 plus 3. The same, yeah. Okay. So I think we can do 4 drawable and index in drawables from the start to drawable. I can end up doing a lot of stuff. Should we see what that does? Which means in here that we can go like nya. You sir, just be drawable dot. What did I call this? Texture data. Drawable dot texture data. If I was smarter, I would have done it like this. So grab. Drawable dot texture data. An idiot. Back. Do that again. Grab all these. And do drawable dot texture data. Reformat for niceness. And then in here, we can just go ahead and say, so it's the index times 4. I'll put an explicit plus 0 just because I think it makes it easy to follow. Right, and then this is index times 4 plus 1. This is index times 4 plus 2. This is index times 4 plus that. Now, actually, I'm realizing means I could do what? I could come down here, stick a thing in there, and go index times 6 plus those numbers. How do we generate this? That's probably less trivial, right? No, actually, I don't think it is. Right, these line up with the vertex values. Your index times 4 plus 0, your index times 4 plus 1, which means we can do the same trick, index times 4 plus, blows up, y blows up. Cast to U32. Why did I get all of that output? What was that about? And then something like that. Put that back where it was. Interesting. Draw drawables does all that. I'm currently not actually calling it anywhere though. Here, set up drawables. We call draw drawables, and we get a letter. But the thing that's nice is we can now go ahead and make another drawable. So let's make these a bit smaller maybe. So let's say 0.1, 0.1, and you're going to be drawables. 1 is going to be draw a ball. I suck at this. Draw a ball. I don't know. Let's make it at 0.25, y is 0.7, z is whatever it is, dimension is, let's make this one not square, so it'll look a little bit funny, but who cares, because it's just an example. Put a B in this one. Right, so we've now put another value into drawables, and we can just draw it. Don't know what I broke in there. Right. And you can see why it's nice, because I can like come in here and be like, actually, that 0.1 should have been 0.2, and it updated all the other values that I needed to get, which is pretty nice. Okay, that all seems a step in the right direction. Do think there's still a bit of thinking to do though, right? So I guess what we've got then is something where we're going to have like game state will have to have a thing that says like, okay, now I want to draw the game state. Maybe we have something like entity. The entity being our like game object. I think this is kind of standard game dev speak. From what I can pick up. So entity will just be anything that exists in quote unquote the world, which will include our UI, basically anything that might appear on screen or interact with anything that might appear on screen. Our game state will have a list of entities. Those entities will have a draw function that populates drawables. And then inside of our draw frame, we'll call draw drawables. Maybe that's the thing to do, right? So that sets up our data. But really, it's draw frame that we want to be doing this. So let's stick that in there. That should work. Didn't work. Well, that's interesting. Why didn't it work? Did I commit before that? I did not. Alright, let's do a bit of undoing. Let's do a commit at the point where it works. So we can get back to it if if we're about to royally screw it up. So work in progress. This draws. Still tidying. Come into here. It's not that these go out of scope, right? Because they don't. Well, I guess like anything local to this obviously goes out of scope, but the drawables stuff is global up here, so that's always there. If I go find where drawables is, it's not going to be an issue with that, I hope. It might be an issue with that. Drawable. Go through, we take the vertex buffer. I was going to say, maybe it's something to do with the... What was I going to say? I thought maybe it was going to be something to do with like not resetting these values, but then that wouldn't have failed to draw. That would have just blown up because we'd be writing out of bounds. Alright, let's go find our draw frame again. That definitely doesn't work. Sorry, go to definition. So we're inside of this. Vertex buffer gets its values each added. Index buffer gets its values each added. And we console log in here. Are calling it. So we do call it for each of those. We're only writing to the vertex buffer once. We're not doing it per frame. Right? Where's our vertex buffer transfer stuff? Got our renderer, vertex buffer. We allocate and map buffer memory. This step now needs to go live in our draw frame, as does the corresponding index one. Jesus Christ. Let's start that line. Yoink this. Go find draw frame. So maybe this actually should have been inside of drawables, but so we can copy. What on earth did I call it? Index. Bigger device queue index. Christ. Where's our index buffer? Why does the index come up so much? There we go. So everything's persistently mapped, so we should be able to do this basically anytime we want to. So we can come in here, go back to draw frame, pop that in there. More horrible programming that would get me sacked if I did it at work. But now it draws. Voila. And this now means that we can update our game state and do a draw with different stuff. It's no longer hard coded, it's now whatever we want it to be. That's pretty cool. Right, let me do a commit there. Because I think I want to have a fanny about with something. Although actually, let's also do a format. It looks like I've got a load of white space I don't want. So what do we actually do in there? So allow, I guess, unhard code drawables. We can update it each frame now if we want. I am slightly curious though, so let's push that just because that's a little chunk. I might go and do a quick run of that through RenderDoc and see what our frame rate looks like now, because presumably it's tanked by that. Right, because we're now having to wait on all this mem copying, which isn't huge amounts of data, but it is non-trivial compared to what we were doing before. What's the easiest way to do this? Let's get rid of you. Let's go to Flectris. Let's do a debug build. A RenderDoc. I like having it here because I've found sometimes you can see error messages coming up. Grab user. We launch it. Okay. Yeah, I guess it is still pretty trivial then. The amounts of data we're moving are very, very low. So we're still seeing multi-thousand frames per second. Cool. Cool. I'm not going to call that profiling, but I was... You know, if that tanked it to like 200, I think we'd have stopped to have a think. But it did not, so I think we're fine. What is left to do then? I think it might be nice to pull these index times values out just for readableness. So if we come in here, can we say vertex base index is index times 4, and index base index is index times 6, and then we can go ahead and say each one of these. Oops. I wanted to see how many of these there are. Oh, a little bit annoying. Can I do this backwards, actually? Can you go... Yeah, boy. I grab all of them and replace them with vertex base index. And replace all of these with index base index. That should work exactly the same. Voila. Beautiful. I like it. Do we want to put our override color in at this point? Just for completeness, because currently you can't access it. So let's do that quickly, which means going to drawable. What do we do? Do we just pass in a value? Or do we want to have like a bool and a value? Have override color be a bool and then color be a value? Which doesn't exist yet, so let's go ahead and say color as a struct with RGB 32. That should then fail to compile. It does not fail to compile. I guess it just turns into a false by default. Isn't terrible. Go find our hard-coded data in here. So you, sir, can have that. Override color. Let's make them both false for now. And then color, I will say, is red. We're going to define some constants, I think. Override color is false and color blue. Go back to drawable. We'll define some constant colors. So we'll say red will be R1, G equals 0, B equals 0. Of course, the Americanisms slipping in. Blue will be a color. R equals 0, G equals 0, B equals 1. Let's go ahead and make green and white and black while we're at it, because they're probably all the ones we're going to realistically use. Stick it in there. Go ahead and say black. 0, 0, and 0, and white will be color R equals 1, G equals 1, B equals 1. That should hopefully compile. That should look exactly the same. And now if we go back to our hard-coded data and we say true and true, it did nothing. It did nothing because drawable doesn't do anything with it yet. So draw, no, draw. Now, let's put that back. Draw, drawables. Find the other place it says it. Nice. So we're in here. These are currently all hard coded to 0, 0, 0, 0. What do I want to say? Drawable.color.r. Actually, these are all going to look basically the same, aren't they? So you're going to be drawable.color R, drawable.color.g, drawable color.b, and what shall we say? Like a value called alpha. We'll go ahead and say alpha is equal to. Does Odin have ternaries or does it just have ifs or expressions? Odin, lang, overview, ternary operators, x if that, else that. Ternary compile time. Fun. Okay, yeah, he's got old-fashioned ternaries as well. He's got both. Stuff, Bill. Let's do the if one. So, if drawable dot color, dot override color, then 1 else 0. What was the thing on it? Backwards. Like that. 1 if drawable.override color else 0. Why do you blow up? Do you need to be afloat? Nice. So we come back to our hard-coded data. And if it's false, we get one and one of the other. Very good. Okie dokie. What do I do? Tidying and override colors. Right. I need a quick wee, so I'll be back in a moment. You see the time jump. Okay, and I am back. Right, just keep an eye on the time. I think I've probably got like half an hour at most. I think what we can reasonably get done. Oopsie daisy. Not a lot if we keep doing that. So where are we up to then? So we can draw our things. We have our vertex and index buffers. We have our drawables, which is like a layer of abstraction above, right? So instead of having to talk about the individual things we're going to send to the GPU, we now have this idea of a drawable, which is still like quote unquote quite low level, right? In that it's still talking about like position on the screen. I think we might be onto something with this entities idea. Let's go ahead and just bump the size of that up as well. Ooh. That's interesting. Did that blow up because we're actually going over all of that every time? Okay, I'll tell you what we'll do. I think the entity thing's something I don't want to rush. Right, so this is changed, right? We're going to want to have a list of entities and a way to build drawables from entities. I think we're going to go up towards draw that. And we're going to have something like draw animated sprite, I think is the next thing to do. Because they're kind of our core things we need to be able to do. We've done this. Yeah, I think the entities thing's something I don't want to rush, but I do think it's a good way to approach it. So kind of what I'm thinking is like, what an example be? If we imagine we have, let's imagine we have like a little guy running. Then he will have a position like in the quote unquote world, and he'll have a size and things like that, which are relevant to your game logic, that don't necessarily map trivially to the drawing logic, right? So the entity is distinct from that drawing logic. So you might have like a zoom level that changes how big he is on the screen, but isn't related to like collision detection, for example. So we have an entity which is the guy for logic's reasons, and then we'll have a like a create drawables or populate drawables that takes in our game states list of entities, populates that drawables list, and then on each frame that gets converted into GPU primitives that get transferred over. That feels quite easy to reason about to me. And it's not going to be as simple as just like this entity maps to that texture. So in our animated guy example, let's say he's got an idle animation that has 3 images in it. Obviously, the same entity will map to different things depending on where he's at in his animation cycle. So I'm not sure how we're going to do that. I guess maybe each entity just has a bit of state for like what tick they're at in their animation loop. Or for our string example, which I think we are going to need for our game, So let's imagine you're going to have the main menu and we want a button that says start on it. The textures we have are individual letters. So you're going to have an entity that is a string entity for start. But then that will generate you out 5 drawables with their positions calculated from the position of the entity, which likely is a relative position from its container. Right, so it's going to be in a box. That box will have a drawable and an entity that says where the button is, and then we probably have a position for the start thing that puts it in the middle of that button. And then the function that takes it will then have to read its parent's position to calculate its position. It'll then have to do that for each of those letters, and then will give us 5 drawables, which will then be converted into the primitives that get sent to the GPU. So you can see there's a few steps in there, but I think that's a set of abstractions that make it pretty reasonable. But like I say, I think it's one to do in a kind of slow and careful way, because I think it's the kind of abstraction that I think if we get it wrong, we're going to end up doing a lot of rewriting. I don't want to rush it in right now. I do think I know why this is currently failing to compile, though. So everything's just fixed size buffers, which is probably a little bit gross. But I guess the positive side to it is our game is really simple. I think this will just allow us to kind of keep a check that things are doing what we think they're doing. And for example, here, what it has caught is, I think in our what I'd be searching for, drawables function. Christ. There we go. We're inside of this. We are just iterating over the entire thing every time, which probably isn't the best way to do this. So I think probably better. Let's just have a drawables count. Might make it capital as well, just so I know it's global. Well, really I use capitals for constants, and these aren't constant. I don't know. Let's just do this for now. So drawables count will be 0. In here we have our hard-coded data. Drawables count plus equals 1. Then we can do that here as well. And draw drawables. We'll just say in here, for drawable in this up to drawables count. And it draws. There we go. These buffers are probably going to end up being much bigger than they currently are, so I guess drawables used to be 20, now it's 10,000, so that might actually be fine. But if we're actually only drawing a small number of things, actually quite likely on the main menu, if we literally have a button that's like start game, I don't know, maybe you have like high scores, create tile set or something like that, right? Like that's the kind of stuff that we're thinking of having. Plausible, we might have literally like 100 drawables total, right? That's not going to be a hugely complicated screen. In which case, it'd be quite wasteful. Let's imagine this ends up having to have like a buffer that can hold 500,000 drawables, because we end up with all, I don't know, maybe we have like particle effects or something that we add later that just massively blows up the number of drawables we're creating. And we do it really naively, like we literally just draw all of them every time as quads. Then it'd be really wasteful to be iterating over the whole buffer. This way we avoid that. We only draw the ones that we know we need to draw. Does mean we're going to have another bit of state we keep an eye on, but we have so much state we have to keep an eye on. I don't think one more is the end of the world. Cool. Let me push that up, I guess. I'm quite pleased with that. That all feels quite neat and tidy. So what do we actually do here? We said only drawables written instead of iterating over the whole buffer each frame. Cool. I think that might be a good place for us to end. We didn't quite get to our drawing a string that I'd hoped to. But I've not got a whole lot of time left this morning. And I think the right way to do that, we could hack it in quickly, but I think the right thing to do now is to take a pause, create this entity idea that will eventually actually live in our game state, and have that entity to drawable to graphics primitives logic set up. So that's one to do next time. I'm looking forward to it. That sounds quite fun. I will catch you next time.